Hi everyone, I'm back with another topic on statistical significance and confidence interval. Often what I observe is that people just go through motion um, for these concepts when they encounter them in school, and I'm also guilty of that. And it wasn't until the first year of my postgraduate in stats before I truly understand this simple but very elegant topic. Right? So when someone say I'm 95% confident of something in a statistical sense, what does it really mean? Let me give you an example. So let's say in a population, there are 1,000 people, but often it's very costly for um, for the government or a company to collect information about the entire population. So let's say if it's in China, if it's in Singapore, it will be 5 million people, right? It might be very costly to collect such information. So what these agencies, companies, or government will do is to collect a sample instead. So for example, instead of collecting 1,000 of the entire population, they collect information from 100 people instead. Uh, and let me use a very simple example. What's the average height of a population, right? But what we can really collect in this case is only a sample, right? And from this sample, let's say we collect information about height, about from everyone in this, from these 100 people in the sample, and you would know the average height in this sample here, right? Take for example, the average height is 1.68 meters in this sample, right? And just now I briefly I talk about being 95% confident. So if you try to recall back from your high school days, usually you'll take the, the, the average height of the sample plus minus 1.96 times the standard deviation of the sample divided by the root uh, size of the sample. But I'm not going to bore you with all these details now. So back to the topic, what is the meaning of 95% confidence? So here, this is sample 1. But in reality, the government or the company could simply just collect information from any other sample, right? It can be like this, it can be like this. These sticks are the average of the sample, right? And some of them might not even contain the true average height of the population. Okay, this could be, this is an unknown unless you have the census data, right? So if you just completely miss the true parameter in the population. But here's the magic pill, right? When I mean 95% confident, it could simply be the case that there are 100 samples, right? 100 of them. 95 of these samples contain the true parameter. So this is what 95% means. It doesn't mean that this true parameter, it doesn't move around in each iteration, but rather you collect information from a sample, you construct a confidence interval, and from there, if it contains the true parameter, in a way you can test for this hypothesis, 1.7, you can see that you are 95% confident. And it's from this concept of sampling rather than the true parameter moving around in each draw, in each iteration. And now to some gory math details. This is the average height of a sample that you draw, plus minus 1.96 times the standard deviation um, of the of the sample divided by root n, right? And back to this formula, what are the implications of root n and this standard deviation? So a large n in terms of the sample size relative to the population, it would mean that because you have more data, your your confidence interval would be narrower, because from the sample you can gain more insights. That's why the confidence band will be narrower uh, around your sample height. On the other hand, if there is a huge variation in terms of standard deviation within the sample, you're less confident. You're less confident about the data that you receive. That's why your confidence interval is is wider. So I hope this provides you with an intuition. And last but not least, to conclude, I've reiterated this in what I mentioned earlier. The true parameter, that is to say the average height of the population, it does not change, right? But rather, it's based on this concept where the information that I receive from a sample is just one of the reality. But in actual fact, uh, the government, the company could carry out these exercises multiple times to collect multiple samples. That's why there is a lot of randomness around the parameters that you see, right? And that concludes uh, my video. Thank you, and I hope you learned something new today.